Hello everyone. We're going to be taking a look in this video at calculating the area of rectangles as well as squares and what would be called complex polygons or regions made up of non-overlapping polygons. Let's start by just defining what is meant by area. It's probably something you guys already know and understand, but just to make sure we're clear, when we say that we're talking about the area of a polygon, what we're looking at is the amount of material that would be required to cover the entire polygon. So sometimes I think of it maybe as the amount of carpet or the amount of paint or the amount of some material that you would need in order to cover that entire polygon. Area measurements are going to be given in terms of square units. So where if you maybe measure the side of a polygon in centimeters, then the area would be given in square centimeters, which is oftentimes written like this, as centimeters squared. It doesn't mean that the number that's in front of it gets squared. It just means that it's a square unit or a square centimeter. If you were measuring in feet, if you were measuring the length of one side of a shape in feet, then the area measurement would be in square feet. Or sometimes we'll just say square units. If it doesn't specify what unit we are measuring in, we'll just sometimes give the area measurement in terms of square units, or sometimes I'll abbreviate that SQ, or square units. So let's jump right in and look at squares. If you notice here, I got a diagram of a square, and I've got it drawn on a set of grid lines. And so if we can kind of think just intuitively about how much stuff is needed to cover this entire square, well, if you think about one of these boxes that's on this grid, if you think about one of those boxes is one square unit, then we could just count the number of boxes that it takes to fill up this entire shape, right? We got a box right here, so that's one. We got another one right here, and that's two. And again, I'm not going to color all them in, but you get the idea. If we could count, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we can say that we can see pretty easily that this square, you would need 16 of these square units to cover that entire square. But of course, there's probably an easier way to do it, right? You might notice that the squares that we have arranged inside this square, the square units, these little boxes that we have arranged inside this square, are in rows going horizontally and columns going vertically. And how many rows are there? Well, there's 1, 2, 3, 4 rows. And how many boxes are in each row? 1, 2, 3, 4. So we could have just maybe taken 4 rows with 4 boxes each and done 4 times 4, and then we would have known that there's 16 without actually having to count them, right? We could have just done 4 rows times 4 boxes, and that would have told us that there's 16 total boxes inside that square. Or we could use the very simple formula that we have from postulate 17, which is that the area of a square is the square of the length of a side. Or you might write this as area equals S for side squared. So as we've already kind of determined over here, we have sides that are 4 units by 4. This square is 4 units by 4 units. Each side is 4 units. All right. So the area of this is 4 squared, which is 16. Squares are pretty simple. Not much complexity there in trying to calculate the area of a square. Rectangles, also pretty simple. If we look down here at this rectangle, again, I've got it drawn on a grid, so we can see that there are a certain number of boxes on this inside this rectangle, right? Excuse me. If we wanted to, we could count the number of boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. That's kind of time consuming, right? And it's just convenient for us that there are these boxes laid out there. So that's probably not the way we want to try and calculate the area of this rectangle. Maybe we want to take a shortcut. Maybe we want to notice that, again, we have rows going horizontally and we have columns going vertically. We have 1, 2, 3, 4 rows, right? There's 4 rows, and each row has 1, 2, 3, 4, 5, 6, 7 boxes in it. So there's 7 boxes going across. So we can just say that if there's 4 rows with 7 boxes, then 4 times 7 would give us the 28 total boxes, or 28 square units for this rectangle. And of course, that's one way, that's another way we could do it. It's better than just counting. But really what we're doing there is we are taking the product of the base measurement for the rectangle and the height measurement for the rectangle. So we could say that the area of a rectangle is equal to base times height. Now you've probably heard it before as length times width. You've probably heard that the area of a rectangle is length times width, right? Area equals length times width is often the way it's taught, or often the way it's kind of referred to. The area formula for a triangle or for a rectangle is often referred to as length times width. I want to stay away from that terminology because we're going to use these words base and height repetitively for a number of different formulas for different types of polygons. So I want to be consistent and use those base and height words, but they really mean the same thing as length and width. What you're going to notice, though, if you wanted to give a definition for the height of a rectangle, it would be the distance between two bases. So if we called this a base, this side in this rectangle that's 7 units long, and the opposite side is a base, so we have maybe a base right here, and we have another base down here. So that's a base, and that's a base. Then the height would be the distance between those bases. And remember, we always measure distances between two objects. We try and measure those along perpendicular lines, which is easy in a rectangle because, of course, the consecutive sides of rectangles will be perpendicular to each other. So this side right here would represent how far apart these two bases are, and we know that it's 4 units. So the base would be 7. So if we were using this formula, it's going to look like a base measurement of 7 times a height measurement of 4, which of course is going to give us 28. If we wanted to put a label on there, we'd say 28 square units, since we didn't give a specific like centimeter or foot unit that we used right there. So that's pretty basic. Area of a rectangle is base times height. Now, where this might get a little bit more complicated is if we're doing the area of a region like this, right? So this would sometimes be called a complex polygon. It's not one of the named polygons that this shape right here doesn't have a special name. It's kind of, it almost looks like what you might see if you were looking at an overhead view of a house or something like that. Something you might see in like some architectural blueprints or something like that. Well, if I want to find the area of this, we do have a postulate that says the area of a region is the sum of the areas of the non-overlapping parts. So let's see how that applies. If I look down here, and I've put this on, again, on a set of grid lines, let's just kind of figure out what are all the different measurements of the different sides of this weird looking shape. We have a side here that's 3, and this side here that's 3. This segment right here is 1, 2, 3, 4, 5 units long. Right here, this segment is 4. This little one here is 1, and this here is 2. Down here we have a segment that's 5. We have a segment that's 2 right there, and a segment that's 2 right there. And then this last segment is 1, 2, 3, 4, 5, 6, 7. Now, I'm not going to just multiply all these numbers together to get the area. It's not the way this is going to work. In fact, there's no specific formula that I would use that using just one simple calculation would give me the area of this kind of goofy looking shape. What instead I'm going to do is I'm going to take this region and I'm going to divide it into a few different squares and rectangles. So for instance, I'm going to put in a line right there that makes a square right here. So I'm going to kind of color that as I go. So I'm going to look, I got this red region right here. Then I'm going to drop in another segment right there. And so now I have this rectangle right here. Then I'm going to make a blue region. And then it also gives me an area down here, another rectangle down here that I'm going to color in green. So now if I want to find the area of this complex polygon, I'm going to first take the area of the red region, which I recognize as a square. It's 3 units on each side. So the area of that is going to be 3 squared, which is 9. Then I'm going to quickly calculate the area of this blue region. Of course, it's a rectangle, so I need to take the base times the height. Well, the base measurement, it's not 5, right? Because that's just from here to here. It's 5 plus this 3 right here, because if I take that measure that 3 unit measurement for this side of the square, of course I also recognize that it would be down here on this side of this little red square. And so then I can add the 3 and the 5 together to figure out that the base of this rectangle is going to be 8, and then its height is right over here. It's going to be 4. So 8 times 4 is 32. Then I got the green region, which is another rectangle. So the area is going to be done as base times height. And we're going to take 5 for the base times 2, this measurement right here, for the height. 5 times 2 is 10. So now, according to postulate 19, all I need to do is take, for the area of this complex region right here, I just take 9 plus 32 plus 10, and that'll give me, let's see, 9 plus 32 is 41, and 41 plus 10 is 51. So that region right there is 51 square units. All right, that's it for this video, and I will see you next time.